Hey guys, welcome to another video. Today's learning objective is to solve quadratic equations, including those that require rearrangement, and that's kind of a higher only requirement, algebraically by factorizing. And there's kind of a few more within this learning objective, but I've broken this down into a few videos to prevent them from getting a bit too long. So the next few videos will kind of follow along very closely to this, just as a heads up. As a prerequisite, really important you remember how to factorize your quadratics. That's kind of key here. And I made a video on that a few videos back about the method behind it. But yeah, let's get into it. So if we have something like a quadratic, for example, such as x squared plus 12x plus 27 equals 0. First thing we need to do to solve this equation is to factorize this on the left-hand side. So kind of pause the video, give this a go, just as a way to remember. Okay, so in case you forgot, we need to find a number that multiplies to 27. So a, b equals 27 and adds to 12. So kind of numbers which multiply to 27. Okay, you have 27, 1. But those clearly don't add to 12. Was it 9 and 3? And those do add to 12. So there we go, job done. So we go x plus 9, x plus 3 equals 0. So that's the equation now. So we just factorize the left-hand side. And now if we want this to be true, right? If we want kind of this whole thing to equate to 0, we need either this to equate to 0 or this to equate to 0. Or indeed both to equate to 0, because 0 times any number is 0. So we plug in, say, minus 9, if say x is minus 9, well, we have minus 9 plus 9, times by minus 9 plus 3, which is minus 9 plus 3, which is equal to minus 9 times 9, minus 9 plus 9 is 0, times by minus 6, which is 0. And again, the same logic applies here. So once we factorize it, the solutions to our equation are just x is equal to minus whatever is here and minus whatever is here. So minus 9 minus 3. You have two solutions because two values of x satisfy this equation. Two values of x mean kind of allow for this to be true. So in general, if you have something like x plus a, x plus b equals 0, x equals minus a or minus b. Or you can say or instead of a comma if you wish. Just as another one, just to ensure we've got this down, say we have u squared minus 13u plus 36 equals 0. So just go ahead and factorize this on the left. Take your time. I'll be right here. So have you done it? You sure you did it? Okay, cool. Remember, a number which multiplies to 36 and adds to minus 13. So kind of, since this number is positive and this is negative, we know kind of a and b are both negative, because kind of the only way we can get 36 as a positive number is both a and b are negative, or they're both positive. But two positive numbers can't enter a negative number, so a and b must be negative. So 36, I think of 36, 1. Those don't, or rather minus 36 minus 1, those won't add to minus 13. 36 square numbers, so I think minus 6 minus 6. That doesn't work. Okay, let's try 12 minus 12 minus 2, because not minus 2, I mean, sorry, minus 12, what's that? Minus 12 minus 3, sorry. Minus 12 minus 3, that adds to minus 15. Minus 9 minus 4, and there we go, that's what we need. So we have, that factorizes to x minus 9, x minus 4 is equal to 0. And x equals minus whatever is here, so minus 9, so that's just 9, and minus whatever is here, so minus 4, which is 4. So that's our solution. That's how we solve an equation through factorization. Just remember to make sure you remember how to factorize, and that's kind of the key thing to do. Sometimes, as kind of the higher requirement is that you have to rearrange. So say, for example, we have 7 over x plus 1 plus 30 over x plus 2 is equal to 12. In this case, we have x's in the denominator, but we can't really solve for them if in the denominator. So what's best is to kind of multiply up by x plus 2 and x plus 1 in order to kind of make our lives a bit easier. So if we multiply kind of both left-hand side and right-hand side by x plus 2, we have 30 plus 7 over x plus 1 times by x plus 2, which is equal to 12 times by x plus 2. And again, we can times both sides by x plus 1 as well to get kind of have this fraction go away. So 30 into x plus 1 plus 7 into x plus 2 is equal to 12 into x plus 2, x plus 1. Now we multiply out everything and then collect the terms in order to get it into a form that's kind of solvable and factorizable, such as this up here. So let's multiply everything out. 30 times by x, 30x, plus 30 times 1, which is 30, 7 times x, 7x, 7 times 2, 14. Okay, and now it's easier to multiply this out, these two brackets out first, and then times by 12, rather than kind of multiplying by 12, then getting to do that. So x times x squared, x times 1, plus x, 2 times x, 2x. Let's write that as a proper x. And then 2 times 1 is 2. So the right-hand side becomes 12x squared, plus 3x times by 12, which is 36x, plus 2 times 12, which is 24. And the right-hand side is, if we collect the terms, 30 plus 7, 37x, plus 30 plus 14, which is 44. What I always like to do is have a positive 12. It just makes my life a bit easier. Sorry, a positive x squared term, the coefficient. So I'll take everything kind of, I'll rearrange it so the kind of I'll rearrange so that this side is 0 and this side is the quadratic, just so it's kind of I have a positive x squared term, which is just my preference. So if I minus from both sides, you know, this thing over here, minus 37x plus 44. So minus 37x plus, sorry, minus 44 from both sides. So then on the left, sorry, we'll get 0. On the right, we'll get 12x squared, 36x minus 37x minus x, and 24 minus 44 minus 20. And now I just rearrange it so the quadratic is on the left and the 0 is on the right. It's just a kind of, that's because that's the way you usually see it. And now we have this. Sorry, that's a very bad looking x squared, so over x rather here. X squared and 0, and that's at 20. So again, what we have to do this time around is kind of split the middle term, because there's the 12 is out, the coefficient of x squared isn't 1. So we need to think of a number which adds to minus 1 and multiplies to 12 times minus 20. So, you know, AB is equal to 12 times minus 20, which is minus 240, and A plus B equals minus 1. So clearly one of these numbers is going to be positive, one of them is going to be negative. Why? Because we've got a kind of a minus 240 here, so the only way it works is, the only way we get minus is one of A or B is positive, sorry, is positive and the other is negative. And because since A plus B is a negative number, we know the larger one is negative. And so with this, it's a bit harder, because you know, you've got a big number like 240. So sometimes what I like to do is on the calculator, you've got you can kind of prime factorize, which is sometimes helpful, or you kind of, instead of kind of doing this mentally, I'll just get my calculator out and say, you know, 240. So I know 240 is, for example, you know, I think, okay, what's 240 divisible? I know it's divisible by 2, but like, you know, something like, you know, something that's kind of a bigger number, and also you're looking for a number that's kind of roughly squarish, because there's only, the difference between the two numbers is only 1, right? When you add them up, so kind of one's going to be negative, the other's positive, so the number between the two is around 1. So if you do square root of 240, for example, you get something around 15, so you can try 15 and 16, and so 15 times 16 comes out to 240, and the difference between them is 1, so that's what I do. So kind of, since the difference here is just 1, right, the numbers will be relatively close together, so you need a number kind of that's almost the same as another that will multiply to 240, and that's kind of analogous to taking the square root, right? So you take the square root of this, square root of 240, not obviously the negative, is something like, you know, 15.49, 49 squared. So, you know, we're thinking that, you know, 15 times 16 or something around that will kind of come out to 240, and it does, and the difference between them is 1. So, you know, A is equal to 15, B is equal to minus 15, no, minus 16. So we have 12x squared minus 16x, so plus 15 minus 20 is equal to 0. So here we have kind of, let's look at kind of 12 and 16 factors there, or, you know, 2 and 4 as well. So we take 4x out, 3x minus 4, and then, you know, oh sorry, this is 15x. Here there's a factor of 5 pretty clearly, so we can take a factor of 5 out, 3x minus 4, which is equal to 0. And then as usual, we will get, you know, factors out the 3x minus 4 from both of these to get that. And then we need whatever, since in this case we've actually got a term, since the coefficient of x doesn't equal 1, in this case what we need is that for this bracket to evaluate to 0, or this bracket to evaluate to 0, for kind of both of them to evaluate to kind of the whole thing to evaluate to 0, by the same kind of logic we had before. So the value of x for which this is 0, so you say 4x plus 5 is equal to 0, so x is equal to minus 5 by 4, and 3x minus 4 is equal to 0, so x is equal to 4 over 3. And those are kind of two values of x. So that was a lot harder of a question, because not only do you have kind of something to start off, you know, like this, where you have to multiply it all out, and then kind of rearrange, and then kind of have this bit of a harder factorization. There's quite a few steps to that. But in general, when you see a question like this, which is, you know, not kind of too uncommon, first thing you do is kind of get rid of the denominators and multiply everything up by x plus 2 and x plus 1, or kind of the denominators in this case. What you should get is then a quadratic on the right hand side, and kind of terms in x and constant terms on the left. Rearrange to find a quadratic which equals to 0, or evaluates to 0 for the right x. So kind of in this case, something like that. And then just factorize it into what you need, and then kind of think of the values of x, which kind of evaluate each bracket to 0, and those are your two things. So there you go. Next video, what we'll talk about is kind of using completing the square, which we've covered in kind of some previous higher videos. And actually, what we'll do first, we'll talk about the quadratic formula, which in cases where kind of things don't factorize so neatly, so if you have numbers that are kind of a bit uglier and don't factorize as nicely, use the quadratic formula. And the video after that, I'll talk about completing the square, which we've covered before, and also as using completing the square to find a proof, or at least showing why the quadratic formula works as well. But yeah, I'll see you guys in the next video then.